for joining our Q&A. Today, we're going to talk about the newly launched WhyLabs AI Control Platform. And my name is Alessya Visnjic. I am the CEO and co-founder here at WhyLabs. I am an engineer by background, so I spend a lot of time at WhyLabs talking to our customers, both executives who are making a plan for how to use LLMs across their business, as well as AI scientists, machine learning engineers, and people who are actually using our platform to operate and control their AI applications. So I'm really excited to share how we build this platform, how we're thinking about this platform, what kind of user feedback went into some of the design decisions. And I'm joined today by Andy Dang. Andy, you want to go ahead and introduce yourself as well?
Yeah, sure. Hi, my name is Andy Dang. I'm the CTO and co-founder of WhyLabs. My background involves a wide range of big data processing, uh, warehousing technology to machine learning platform, and a little bit of AWS SageMaker and security. And these days, I focus on integration and deployment in the context of WhyLabs users and customers. I enjoy, because I'm an engineer, so I really enjoy learning about all the interesting use cases that our users, the LM users and communities is building around LM and various integrations these days. And I'm happy to share some of the learning here today with everyone here.
Thanks, Andy. Super excited to spend the next 55 minutes together with the listeners. A few housekeeping items. So this is a live stream, and we could be watching it on YouTube or on LinkedIn, depending where you joined. Please ask your questions in the platform, and we would love to answer them. We have a few people monitoring, and no matter what platform you're watching, feel free to send us questions. Also, if you happen to be on our community Slack, feel free to send questions there. We're monitoring across all of the platforms and are super excited about your questions. And if you've sent us questions ahead of time, we'll make sure to answer them as we go through the demo. So why don't we kick things off? And the first thing I want to talk about is kind of the new vision of the platform, and where did we land, and why are we focusing on AI control? So for those of you who are previously familiar with WhyLabs, we have been focused on observability. The company was founded in 2019, and AI observability was one of the top issues that customers would highlight that they need to systematize and need to create a kind of a culture and a process around observability across the company. So WhyLabs platform was focused on observability. However, sometime in the beginning of last year, there were kind of two trends that were happening. One is the LLM trend, and the second one is a trend in observability. So first, I'll talk about the trend in observability. As our customers started implementing observability and relying on observability to understand the trends in model performance, the trends in model drift and data quality, they began needing more and more real-time intervention techniques. So last year, for predictive models, we launched capabilities that allow customers to identify outliers and interfere in case an outlier is detected, and make certain decisions in the pipeline with these outliers. So that gave the start to what we call real-time intervention, which is a range of capabilities. It's an umbrella term for a range of capabilities under our secure component. The second trend that started happening is, of course, the adoption of generative models, foundation models, large language models at various teams that we're working with. And one of the big issues that teams started encountering is the fact that observability was simply not enough, because observability allows you to look at trends over time. And the best case, you would notice that something is happening with your application 15 minutes later or an hour later. And that was simply not enough, because if your application is being jailbroken jailbroken or prompt injected, you cannot wait for the time for observability to catch a certain change in the trends. You need to be able to decide on an individual prompt whether this prompt is adversarial or not, or whether this response is untruthful or not. And then based on this decision, you steer the customer experience with the AI application. So that requirement and that need gave birth to the secure component of our platform, which we've been building and beta testing with our users for the past year. And as we started looking at the observability and the security needs, we realized that these two activities come hand in hand, and you have to be able to do both to really understand how to control your AI application. So what we've done is we put both components in one platform. So if you are running security, deciding how your application should act based on certain data that you're getting from each prompt and from each response, and you're guardrailing your application, you should be able to debug using the traces that you're capturing from this very complex, probably LLM-powered application, as well as you should be able to see how does this application behave over time. So you're making a decision on to block an individual prompt, but you also should be able to see how many such decisions are you making and what else is happening with your prompts over time and with your responses over time. So that brings observability and security kind of under one umbrella. In addition to that, we realized that as we are guardrailing the application, we are identifying prompts and responses that are not in line with the policy. And effectively what we're doing is we're labeling prompts saying this prompt is very similar to a jailbreak, or this prompt is very similar to a prompt injection, or this prompt is very toxic. And the same thing for responses. This response does not match with the context, so it's unreliable. This response contains toxic information, or this response does not answer the question that the customer asked. So we're effectively labeling prompts and responses. And then these labeled data sets become very, very useful. So in addition, we also added a concept of optimization, where we, using the information captured, using the data captured during the guardrailing phase, we help our customers build evaluation data sets and red teaming data sets so they can use these data sets to do model migration. So when they upgrade from one version of the model to another, or when they're doing iterations on their prompt engineering techniques, or they're making changes to the RAG. So they're able to use these data sets and run them through their new LLM experience, new version of their LLM application, and see whether the labels with responses being untruthful or responses being toxic are the same from the new model or better. And then with responses that come from prompts that are prompt injections, whether the responses are more in line with the policy or not. So this data allows us to create a full feedback loop. Now, these are the three kind of components of our platform and how we think about it. I'll highlight a few other very important things of how the platform operates. So the first is the fact that the platform works across any type of model, and that's the very kind of foundation of how we think about it. That's the very bottom layer. And what's important to our customers is the ability to use any model, be it a proprietary API or something that is self-hosted from open source, or something that they have developed in-house, or LLM capabilities that are offered by cloud companies like AWS Bedrock or Azure Model Catalog. So depending on where the LLM is coming from, the infrastructure could be different. And we spend a lot of time at WhyLabs making sure that we can serve all of these use cases. Now, the second aspect of our product and architecture, which is very key to how this platform works, is the fact that we integrate using privacy-preserving agents. And Andy is going to spend some time at looking at the container architecture and kind of walking us through how the actual privacy-preserving integration works. But here I'll just point out that we integrate in a way that does not take your raw prompt and responses out of the perimeter where they're already being processed by the LLM application. We do not send prompt and responses to any third-party vendors, and that is very key to our customers. And lastly, the third layer is around different modes that we support. So we make sure that however you choose to develop your GenAI application, whether there's some uh, completions that are running in batch mode and or real-time mode, those are supported. We'll talk in depth about our SLAs. And in addition, whether the application is running as an API, whether we have a containerized deployment that we can integrate with, whether there are vector databases that are being used that we can utilize in actually asserting certain things about the application health. We make sure that we integrate in all of these aspects of your application and can help you protect all of these aspects. I keep monitoring questions, so let me know if you want me to double click. I'll be happy to go back to this. I'll really quickly talk about kind of the thinking of how we arrived to this platform. And this really has been an amazing journey that we've been going through together with our customers. And we work with a wide range of enterprises. We serve 7 Fortune 500 companies and a number of global 50s. We work with organizations in fintech, finserv, healthcare, retail, e-commerce, real estate, HR tech, a wide range of customers. And thanks to these customers who've been kind of pushing the envelope of what's possible with observability for AI, with security for AI, we have been able to land on the platform as it is today. We really built together with our customers hand in hand, and we prioritize the requests that they're making, which is why we are so proud of what we've been able to accomplish. And so far, the new onboardings that we're doing with the new teams have been really well received. And the platform has been used by a large number of teams across organizations. We've seen more than 2.5 million of installations of our privacy preserving agents to integrate with the platform. So you can imagine kind of the number of different endpoints that are being monitored using our privacy preserving agents. And also with the features that we're rolling out, our customers have been able to rely on the platform more and more for more types of use cases. So for example, they rely on the platform to alert them when there are certain drifts that are happening in the models. They rely on the platform to alert them when there are data quality issues. And now they rely on the platform to enable guardrailing for LLM applications, as well as to alert them when there are certain trends in LLM health that are happening, negative trends. So I want to express gratitude to our customers for all of their amazing requests and thinking through the capabilities with us. And continuing to kind of push the envelope and continuing to challenge us to launch new capabilities. So really quickly, before we dive into a hands-on demo that Andy is going to run, I want to settle on kind of the two products that we'll talk about. One being the WhyLabs Observe. So this is the observability capability that many teams have been relying on for a number of years now. And this observability capability, we have been growing and expanding to make sure that we can serve LLM use cases. And with this observability capability, our customers have been able to see ROI from their AI investments 2 times faster because they can iterate through models and improve models much faster, as well as they can catch model degradations before they impact many of their end users. In addition, with WhyLabs Observe, we've seen teams get to over 70% higher efficiency of their operations because they're able to automate a lot of the manual work that they've been doing before, manually checking whether the model performance is not degrading, manually checking whether there is training serving skew in their models, manually checking whether their LLM applications are increasingly becoming more toxic or less helpful. and so on. And lastly, it's about reliability. So our customers have been able to reduce time to resolution. In some cases, we've seen a reduction by as much as 10 times, going from many months of identifying, debugging, and resolving the issue to minutes. Because WhyLabs, in addition to surfacing alerts and giving our customers root cause analysis tools, we also enable automation. So you can configure to automatically resolve issues, configure to automatically retrain the models, configure and-on cords and circuit breakers in your pipeline, so you do not actually promote something in the pipeline that would potentially cause harm to the model performance or to the customer experience. So that's WhyLabs Observe. Now, WhyLabs Secure is focused on real-time prevention. And here, what's important is catching things like prompt injections and jailbreaks and harmful interactions. And we have been hard at work creating specialized models to identify prompt injections and jailbreaks, building an architecture that allows our customers to warm start the guardrail, providing their own examples or their own proprietary data around prompt injections and jailbreaks. And we see accuracy north of 93% in catching these harmful interactions. In addition, here we're really focused on privacy of your data. And WhyLabs Observe, we're also focused on privacy, but here this privacy is further more important, because there are solutions that require you to send your data to a third-party LLM, for example, to extract whether it's a prompt injection or a jailbreak. And as we're serving customers in highly regulated industries, what's important for them is that all of this information, whether something is a prompt injection, whether something is a jailbreak, whether something is toxic, all of these decisions are extracted locally without sending data anywhere. So the solution that we've built is running completely locally, handling all of the raw data without any kind of third-party interactions. And then the last thing, very important, is the latency. So here, you're making decisions about prompts and responses in real time, and latency is very, very key. So keeping this down to about 300 milliseconds has been important for our customers to be able to use WhyLabs Secure in real-time AI applications. I'll pause here, and I'll be handing this over to Andy, who's going to dive much deeper technically and walk us through a demo of first Ylabs Secure, answer some questions, talk about the deployment mode, and then we'll talk more about Ylabs Observe. Thank you. Thanks, Andy.
Thank you, Alessya. Yeah, just jumping into the secure aspect of YLabs, this is the view of our policy page. And really the goal of this page, what we're building here, is to try to simplify a wide range of problems that we see commonly seen among our customers, as well as trying to simplify the workflow of configuration, the detection and the actions for these problems. The reality is that there are a lot of metrics you can extract from the various LLM interactions, and when our customers encounter these metrics, it can be a bit overwhelming, and also each of these metrics have like complications around how they are computed from the data science angle, and there's a lot of optimization around how to think about sensitivity. So we categorize at the top, very high level, what we call rule sets, and these are built-in rule sets by YLabs. Our customers can also customize them further. They are backed by our internal heuristics, as well as well-tested, bio-tested open source techniques as well. Just to walk through each of these rule sets here, the first major one is bad actors, and these involve, the commonly discussed ones like prompt injection, or in case of like private, or in case of hallucination risk, or in case of detecting like bad language. So those are malicious actors that we try to detect when it comes to the LLM. And then with each of these policies, user can then flag or observe or block the actions, depending on what they want to do. We allow customization for each of these sensitivity and each of these actions as well. And the second category is misuse. So this is where the LLM typically, for example, a common story that a lot of LLM practitioners have been talking about in the last few months is the Air Canada use case where the chatbot was discussing something it wasn't allowed to discuss, like pricing policy. And that is something that we hear from our customers well, where retailers or specific provider platform, they want to make sure that the LM only discusses topics within the range of allowed values. And then we can monitor based on this topic. We take all of these in real time. In this case, a topic detection model takes about 104 milliseconds, for example, on average. And another kind of vector of attacks, and this is going back to the OWASP top 10 of LLM risk, is really the cost aspect. Because if you have a malicious actor sending a lot of expensive requests with expensive tokens, that can trigger the unexpected increase in cost for your LLM, especially if you're using some SaaS-based LLM like OpenAI rather than self-hosting the LLM yourself. Obviously, all of this can also degrade the customer experience, because you might experience latency increase or rate limited by the LLM provider. And then customer experience is a bit more complex, because this is specific to the industry. We take a lot of heuristics and look at not just one single interaction, but the history of interactions, for example, and including the feedback into the loop as well. And in this particular flow, we really focus on figuring out what are the signals that really can indicate a degradation of the customer experience, whether that one specific customers or it can be a wide range of customers. So maybe one particular customer's experience, based on the various feedback. If you receive negative feedback from one particular customer, they might be unhappy. If you receive multiple feedback from multiple customers at wide scale, then maybe your service upstream is experiencing something abnormal, and that can be so the LLM itself can be something else. And then truthfulness, this is when the LLM hallucinates and giving incorrect answer, not grounded especially when you think about RAG context. Typically, the LLM can hallucinate and generate answers outside of that. That can be problematic. Especially, we see this as a huge concern in LLM applications for financial use cases like document summarization or legal use cases. So we really focus on whether the LLM topics are relevant, the answers are relevant to the questions, as well as the RAG context, as well as using LLM-based technique if user wants to detect like hallucination, similar to the various latest research have been publishing on various ways. So this is something we iterate constantly and allow our customers to customize well, because some of our customers are interested in these based on the different interests, based on different latency, whether it's kind of background monitoring use case, or whether that's something that they want to do it in real time. And we've seen both use cases of like needing to audit LLM behaviors historically, as well as needing to observe and manage this behavior in real time. And part of this management and I mentioned a lot of these management challenges. Part of it is how we can plug into the customer's infrastructure in a seamless way. And this common pattern in our integration is really the callback pattern, where we really send these various signals that we detect back to their own infrastructure, so they can aggregate and manage this into a central database, typically a webhook going to a messaging queue, and then could go to human moderator, could go to some automated system that manage the health of the LM and surface visibility across the organizations. And another thing, on top of what we call the rule sets, we also expose internal implementation, where you can look at more like metric specific behavior. So this is more on the kind of like implementation details, but this is a further level up in terms of like complexities. And some of our customers do go down this route because they are technical and they want to manage this and version this. This is all backed by versioning, but they want to manage this policy rules in their own internal code base and have their own workflow around this. So that's one part of the workflow. And here I'm just going to turn on a quick view policy and then turning on various observe behavior here. And I want to jump into the how what it means, what it translates to in the background. Once this save behavior is done, it's not magic, it's all engineering, obviously. And what our platform really provides is really the ability to version, centralize, and manage these policy documents. What happens in customers or your infrastructure here is really mostly most importantly, our WhyLabs Secure deployment. And that comes with it posts down the policy document. It also has its own internal processor for storing data in your infrastructure. What this API, this basically deployed as a containerized service, typically in Kubernetes, the Helm chart. It can be in ECS. Some of our customers are deploying this in Lambda as well. It is built for commodity hardware, so you can scale the solution wherever you have commodity hardware. Obviously, the hardware does make a difference in terms of performance. Like if you're running it on AWS Lambda, it is going to be different from running it on a dedicated instance in Kubernetes with latest CPU from Intel, for example. But yeah, the goal here is to be able to really what our customers find most valuable is to be able to scale the solution as part of the infrastructure, and there's a lot and very cost effective because we don't rely on any GPU based processing at all. What happens is that you can instantly scale up the cluster, for example. Anyways, the application runtime typically or can be an LLM gateway, depending on how you structure this. We make it very flexible. The secure API endpoint itself is a REST API. You can call it in JSON directly into that, and you get you pass in the prompt and the RAG context or the list of prompts. And then the secure endpoint can also validate the response from the LLM. The integration is seamless, and I will show you an example of how that might look like. There are many ways our customers are integrating this because it's an API. You can drop it into your application by calling it directly, or you can do it the seamless way using our open source what we call tracing instrumentation agent. And all of that will take care of the interaction here. But the result that comes back to WhyLabs is really the health signals of the LLM, including various metrics and various what we call traces. And I'll give you a walkthrough of these in the next part. And yeah, and just something else to call out is that this architecture has been battle tested for latency. We see really large scale real-time use cases with hundreds of TPS scaling on commodity hardware. And these customers are running on using techniques like spot instances to really cut costs and saving on this because they can cut the cost by 40%, for example, using spot instances. And all of these are built for using stateless approach. So you don't really need any persistent storage here to make the container fast. Let me jump into what it looks like from the application side. And this is my Colab notebook. It's not that exciting, but what I want to highlight is really our open source library called Open LLM Telemetry. It is a mouthful, but we're trying to make it obvious as well. And what it does is that it has integration with popular LLM providers like OpenAI in this case, and it applies instrumentation technique underneath the hood. So you don't need to modify the main application code. What you really need to do is really making sure the WhyLabs endpoints are set up. In this demo, I've already deployed my endpoint to a secure IP address internal to us, or I have set up the API key here. So when you, when you call the instrumentation here, it actually will prompt you for various information like the API key for WhyLabs, so we can send tracing. You can also pass in the endpoint information if you want to enable various metrics and metric extraction and guardrails, and then you specify the default model in WhyLabs that you want the traces or the instrumentation information to go to. And that's it. Out of the box, once you have this set up, then you can run the OpenAI code and we will instrument it in the background. You don't even see it. If you enable logging, you can debug logging. You will see a bunch of traces being pushed to WhyLabs. I will show you what they look like on the WhyLabs side, but from the instrumentation perspective, this is actually based on open telemetry tracing technique, very standard form. It works well with a wide range of technology. We want to make, and also this has the benefit of, you're not having to change your application code. And then let me jump into the secure, what the output looks like once you start running this workflow over time in real time across the application. So this is a view of our of the various interactions over time. So out of the box, we build very standard dashboards with various information like tracking the interactions, tracking the ones that have policy violations or not, and then tracking token costs, for example, or latency. Just standard workflows for open telemetry, and using both a combination of like the token information from the LLM provider as well as our proprietary metrics on top of this. And these charts are typically customizable and configurable by the customer. Some of our customers care about one metric or the other, or they have their own internal KPI. And because this is built on top of open telemetry, you can inject your own metrics into the tracing flow as well. I don't have a demo here, but it's a pretty standard way of adding attributes to a span in the world of open telemetry tracing. So what does it look like once you have a trace? So here's the view of the tracing over time here, and each of these traces is basically, we track them over time. Each of them is typically a conversations, and here I'm just doing one interaction, so I'll click in one of these, but they're kind of not that exciting. I'll show you something more exciting later. And then each of these interactions get flagged by our secure API, for example, for PII leakage, for toxicity sentiment, and or you can flag it with your own custom tags as well. And then they typically people will map one particular like conversation into a trace, so you can see like multiple LLM interactions over time. In this case, it's just a very simple open API call. So we compute a wide range of metrics. This is what I describe as the underneath the hood implementation details of these metrics, and they do get can be get a bit overwhelming from the customer experience perspective. That's why we build the rule set on top of this. But then you can also see the actual LM interaction being traced here. Notice that we don't capture the raw prompt and responses as part of the trace, because our customers also find the raw LM data story very challenging, even internally, because if you're a retailer and you're dealing with chat data, customer might drop in credit card information, for example. And so is it a critical data set? Is it just a kind of like standard public chat data set? There's a lot of debate going on among our customers trying to figure out how to handle LM respond requests and responses correctly from the data security perspective. And we're working closely with them to make sure that our integration fits into that their architecture, regardless of what approach they're taking. Oh, I see some questions coming in. Somebody is asking about configuring the bad actor rule set. I want to jump back to this a bit and then going back to the, I think I'm going back to that page. So let me jump back to the policy page. At the moment, the bad actor rule set is aimed to be really simple. So you can configure it at when you in the UI is aimed to be really simple. So you can specify the sensitivity and the behavior. Underneath the hood, you can configure what metrics go into the rule set out of the box. I believe we take toxicity, we take prompt injection score, like how similar it is, how likelihood this is will be a prompt injection, and that and then we know we map those. We have a internal algorithm to normalize that based on historical data across customers, as well as various open source like open research that we have, and that gets mapped into this bad actor score here. And our customers can configure it. If you, for example, if some of customers care more about like code, people passing in code, like hacking attempt or getting the LM to generate code that is, it's kind of a misuse, but in this case more like hacking attempt, like execute this code and then give me the result, for example. That is kind of a bad actors use case, and we do have customization there, but it's mapped, and basically each of these rule sets get mapped into rules, and the rule looks like, you know, you take a metric, and I don't have an example of rules here, but they have a bunch of metrics, and each of these metrics get mapped into various thresholds and various behaviors. Feel free to ping me after this if you want more specific details, because this is something that is evolving. We have documentations and our doc site as well regard to these configurations. So jumping back to the trace view, I was describing the trace view of, in the context of, oh, sorry, I just lost my tab. If you go to the our demo org in the main, I'll jump into the endpoint callback a bit later. But if you go to the demo org in our demo environment, if you sign up to WhyLabs, you'll find the demo org. You find an example LM trace here, and this one is a bit more interesting. It is more of a multi-turn interaction with RAG flow built in, so including the RAG chain. Here, this one we break it down to the prompt guarding. There's a RAG flow internally where we retrieve documents from Wikipedia. I mean, nothing exciting because Wikipedia is public. And then calling OpenAI, and then also figuring out where the various, in this case, the LLM response was flagged because there's some customer experience risk being flagged here. And then there's another second attempt in the same conversation where the LM again refused to answer the questions from and this is again flagged from the customer experience perspective. If the LM keeps refusing, then maybe, for example, in this case, the customer should be redirected to some human interaction, for example. But that's that this is, you can explore this in, there's a lot of interesting traces here where we try to we have like various interactions in the chats here for you to explore. I want to jump back to the callback example. So callback at the moment, yes, they do provide real-time notifications. That's one of the main use cases that our customers build on top of this. So we, at the moment, is typically a webhook. That's a standard one. We also support SQS and SNS because those are very common Amazon technology using for notification, and a lot of our customers are on Amazon. But we support is very flexible from the extensibility perspective. User can actually roll your own quote unquote user-defined callbacks. It's basically a Python functions. You can pass in your own credentials and your own clients. You can build it as a layer on top of our existing container, so you don't have to really deal with like dependency management and whatnot. And yes, they provide real-time event notification. The a common use case we actually see is streaming this into some security system like Splunk, for example. Is there any other questions before I hand it back to Alessya? And there's feel free to ping us. We're on the community Slack, so I'll hang out there. Thank you. I hope that answers the questions.
And thank you, Tom. Thank you, Andy. I hope this was a great overview. I'm going to take over and help kind of close the picture of how the control platform goes from real-time prevention of certain undesirable behavior to observability, which is also very powerful and important, because understanding how the model behavior evolves over time is critical, especially with proprietary APIs, as there are updates that are happening to the APIs that you're typically not in control of. GPT 3.5, GPT-4 are especially kind of notorious for these changes in behavior over time that you need to monitor for. So as you're running the secure guardrail, and whether you have configured the secure guardrail to block certain undesirable behaviors, or just to flag undesirable behaviors, or just to observe, automatically you get observability. And what I'm sharing here is kind of an overview of the health of this OpenAI guardrail demo model that we have. And here we have kind of a range of health metrics that we're tracking. So security being one of them. And this is what Andy walked through with configuration of different rule sets in the security policy. We also are tracking a wide range of other telemetry. So as the rule sets are composed of different specific metrics around model health, LLM health, prompts and responses, we're capturing this telemetry. So this allows us to enable observability over time. And in this case, we're essentially looking at the behavior of the model hourly, hour over hour. So we have an hourly batch frequency. I'll jump into the Telemetry Explorer and show you kind of exactly what it looks like and the types of things that we're catching. So here you can quickly identify that there's a range of prompt-related metrics as well as response-related metrics that we're capturing. And it's a pretty wide range of different metrics, everything from injection, whether the prompt is an injection, or there's a similarity to a known jailbreak, or there's a sentiment that is particularly low, whether it has regular expression patterns or PII data, toxicity, and there's a wide range of kind of qualitative metrics that we're capturing and so on. So as we're capturing these metrics, we can watch how these patterns change over time and identify when there's a trend change in the LLM behavior or in the customer behavior. So in this case, we're seeing that there is a data leakage event because the response we identified that there's some responses that contain email addresses and phone numbers and social security numbers. And we didn't see any instance of data leakage before this. And the guardrail potentially either blocked or flagged or observed this, depending on your configuration. But what's important is that this is a new occurrence. So you can quickly analyze that this has not been happening to your LLM experience before, and this just happened for the first time. And you can start your investigation from here. You can drill down all the way to the actual traces and look at what's happening at this individual prompt response level. So the zoomed in version of what Andy was showing earlier, now zoomed in into a particular time period of when the issue was occurring. And we can go in and see the specific traces that do have indication of PII leakage. And going in and drilling down into this individual trace, we can see the output of the guardrail and explanations of what were the instances of data leakage. So for example, here we've identified a URL, and here we've identified an email address, and here we identified a social security number. Notice that there's no raw data, so you're not actually capturing the raw data of what was in the response from the LLM. Instead, you get the information about what was identified there, and then you have the IDs, which allow you to join back with your individual raw prompts and responses if you need further investigation. But this capability is very important. It's very important to separate the raw prompt response data from the information in the guardrail, because depending on who is debugging this, they might not have access to the raw data. From compliance perspective, they might not be allowed to investigate the raw prompt response data because it contains sensitive information, which is why we separated these concerns. Now, diving back to the observability capabilities of this model, and I'll zoom out to a little bit more time to make it interesting. In addition to telemetry, which is very helpful to start understanding kind of the relationship across the things that are happening. And even at this particular view, you can really quickly see that there was an event that happened on March 1st at 1400 UTC that triggered prompt injections, jailbreak similarities, and PII leakage. So it's a signature of an event that you can identify visually really, really quickly without any kind of multiple dashboards that you're building or any kind of data extraction. So just looking at the signatures of these events, you can start investigating super quickly. In addition, we've built a range of dashboards which are tuned to a very specific user persona. So for example, if you have a security team that is keeping an eye on the health of this LLM application, they can have a dedicated security dashboard, which has this analytics summarized from security-specific issues like prompt data leakage, or prompt injection, jailbreak similarity, sentiment. And this is customizable because sometimes you want to start with the default WhyLabs set of metrics that your security team cares about, but oftentimes your security team might add additional metrics that they care about, or they may want to remove, or they may want to build their own types of dashboards. So the out-of-the-box ones that our customers find particularly useful are security and performance touches more on like readability and the quality of the text output that LLM was producing, but again, it's completely configurable. And what's important here is you can compare it to other models that you're running if you're doing A/B testing, or if you're rolling out a new version of the model and are running in shadow mode with your other model. You can compare the models, or if you have ran two kind of red teaming exercises, you can build these dashboards to compare across two different model runs. And you can also segment the data. So you can segment your model runs across customer types and drill into a very specific customer type and understand the model behavior as it pertains to a specific customer. I'll take a second to see, I see there is a question from Marie. Typically, how long does it take for traces to show up in the platform? Andy, do you want to take on that?
Yeah, traces show up in near real time in the platform.
Marie, let us know if you want to try out the secure capabilities. We have a 14-day free trial. Feel free to ping either Andy or myself. We'll gladly walk you through the capabilities and help integrate. And then there's another question from Tom. How much work is required to set up these dashboards? So setting up these dashboards, everything I've been showing you so far is out of the box. So we have out of the box security dashboards, out of the box performance dashboards. All of these telemetry, explore visualizations are built out of the box. Essentially, all you need to do is define which policies you care about in the policy config, which is here. And once you have defined the policies and saved the policies and deployed, all of the dashboards are built automatically. In addition, we do have capabilities to build completely custom dashboards. So a range of these dashboards that I was showing are customizable. You can build your own security dashboards. You can build your own standalone kind of specialized metrics dashboards, or you can add your additional telemetry to be captured, customizable telemetry, and they will show up automatically. And anomaly detection capabilities. Thank you. That's another great question. So when it comes to observability, obviously you want to detect changes and trends. And here we have the monitoring capabilities, which we have been serving to identify issues with predictive models. And we have a wide range of different anomaly detectors. I'll go through kind of a quick UI builder where you can build detectors to recognize drift or data quality issues or model performance. And then the data quality, there are all of these different metrics, categories of metrics that you can build a detector around, or in drift. There are a range of different algorithms that you can use to recognize drift. You can come up with very simple threshold-based metrics, configurations, and so on. And as you are configuring the metric, configuring the monitor, you could choose whether you're monitoring all of the metrics that you're gathering, whether you're drilling down to specific segments. You can choose what is the baseline. You can use a baseline from your evaluation exercise, red teaming exercise, or you can use a rolling baseline. And then finally, you could configure how you're getting notified, where do the notifications go. And in addition, we do have a way for you to create custom workflows, basically via webhooks. If there is a certain monitor that's firing, you can use this information to, again, like halt your pipeline, create circuit breakers, or escalate into a particular workflow in your organization. The monitor is very powerful. And actually, one of my favorite features in the monitor is the fact that you can fully build the monitor via JSON, and the resulted monitors are fully configurable. Which is very important, fully templatable, which is very important if you're trying to roll this out across many different teams in your organization. So you can come up with a config for your monitor that, for example, will make sure that toxicity never trends above a certain threshold, that PII is not allowed in any of the responses. And this config will be applied across every single LLM that is monitored by WhyLabs, and you will have a very easy rollout of these standards that you want to enforce in every production LLM application. I hope this was helpful. I know we have about 4 minutes. Tom, let me know if this answered the question. I'll just really quickly highlight that all of the capabilities that Andy and I have covered today are already available. We've been running the Ylabs Secure capabilities with a large pool of beta customers for the past 8 months. So as we roll this out into general availability, all of the capabilities are well battle tested, and we're excited to start onboarding more users. We have a bit of a wait list right now, but the base case of the deployment is available as a 14-day free trial. So you can easily log in. You can easily go to WhyLabs and switch over to our pricing page, go to secure and request access for the 14-day free trial, and we'll be happy to walk you through. I'll stop screen sharing, and I know there are a handful more questions. Andy, do you want to take on the templates on GitHub?
Yeah. All these the monitor configurations can be configured via API. So it's common for our customers to actually store them in CI/CD pipelines via GitLab or GitHub, and we have open source client to help manage this as templates as well.
Thanks, Andy. And I'll add to the answer to Cal's question. Thank you for the question, Cal. So when it comes to toxicity and how we help mitigate it, it really depends on the use case. Again, one of the kind of straightforward things that you could do is define rules of kind of the degree of toxicity that you are sensitive to, your application is sensitive to. And you can say if toxicity is above a certain threshold, I want to block this prompt, for example, from going into the LLM, or I want to block this response from going back to the user, and instead have some kind of system message that I return. In addition, you could just flag toxicity issues, and when you flag toxicity highly toxic prompts or highly toxic responses, what we help you compose is essentially a data set, a labeled data set of like toxic responses in your specific LLM application. And then as you're iterating on prompt templates or moving from one model to another that potentially was built on a kind of a very specialized, not Reddit data set, but a very specialized non-toxic data set. As you're migrating from one model to another, you can use the data that we've gathered while monitoring your LLM application that specifically has to do with toxicity of responses, and use those responses to evaluate your new model and continuously improve kind of the overall toxicity susceptibility of your LLM application. I hope that helps. All right, this has been really fun. Would love to do it again. If anybody has specific questions, feel free to throw them into the LinkedIn stream, into YouTube on our community Slack. Andy and I will do our best answering them offline. And if there's an interest, we'd be happy to do another dive deep session on any of the capabilities that we have demonstrated. So let us know in the comments. Thanks a lot, and thanks for joining. I hope you have a fantastic Thursday.
Yeah, thank you, everyone. Thanks for the questions.